In this video, we are going to solve a few polynomials by factoring. So remember, the process is going to be to factor something and then set each factor equal to 0 and then solve that new equation, essentially. We've done this before with quadratics, but now we're just going to extrapolate into higher degree polynomials. So here in question 31, the first thing that I'm going to always look for is a GCF. In this case, 5 and 10 have a common factor of 5, but better than that, x to the fourth and x squared have a common factor of x squared. This is why we had to use our exponent properties. So this tells me 5x squared times x squared and 5x squared times negative 2 are going to be the same thing as 5x to the fourth minus 10x squared. If I were to distribute, I'd get that same thing. This is why we talked so much about factoring out and not dividing back in our quadratics unit, because now I'm going to set 5x squared equals 0 or x squared minus 2 equal to 0. When I divide here, I'm going to get x squared equals 0, which I take my square root of. I'm going to get a double root here, because square root of 0 is 0. But when you take a square root, normally you get plus or minus. There's no such thing as minus 0 or positive 0 for that matter. It's just 0. So we get two solutions there. And then x squared equals 2. X equals plus or minus square root of 2. So my four answers are going to be x equals 0 double root. That counts as 2. X equals plus or minus square root of 2. This highest exponent will tell you how many answers you should have. So I should have 4 answers, the 0 double root being 2, plus root 2, minus root 2. That makes a total of 4. Okay. In number 32, when in doubt, get everything to the same side to start. We are going to end up with a tetranomial. Make sure we subtract 2 to get over. And then in that tetranomial, we are going to worry about factor by grouping. So I changed that minus x to a plus minus x. That should hopefully help us find a common factor. But in the red parentheses, my common factor is x squared, leaving behind x plus 2. And in the green, my common factor is just a minus 1. Okay, I factor that out to end up with an x plus 2 so that they match. So now I've got x squared minus 1 times x plus 2 equals 0. Now you're in a situation where you can go one of two ways. You can set each of these factors equal to 0 and solve, but because this first one has an x squared, depending on the numbers, that could get a little dicey. You can recognize this as a difference of perfect squares. So instead of x squared minus 1, I can write it as x plus 1 times x minus 1. Now I have x plus 1 equals 0, x minus 1 equals 0, x plus 2 equals 0. So I end up with x is negative 1, x is positive 1, or x equals negative 2. Okay, that problem went very, very quick. But again, it's our factor by grouping, which we were already practicing. We had an exponent of power 3, so I should get 3 answers. Negative 1, 1, and negative 2 give me 3 answers. I didn't write them in any particular order. If anything, put them smallest to biggest, I guess, but I don't really care as long as you have all 3 answers listed, unless I tell you to write it specifically a different way. Okay, so I don't want to get too in-depth on one video, so we'll pause here. Next video will be the next couple of examples with more factoring, solving by factoring. Have a great day, everybody.